We've been working with factoring for a little while now. We've done greatest common factors, and we've done factoring of special cases for quadratics. What we're going to do today is look at how to handle factoring for non-special cases. So for things where the linear factors are not a difference of squares and not creating a perfect square trinomial. So something like this, 3x squared plus 18x plus 15, it has a GCF, but it's not a perfect square trinomial. So it can't be factored using our special cases, but it can be factored. So we're going to follow these steps to go through how to factor this expression. Do note that not every quadratic can be factored. So it can only be factored if it has x-intercepts that are rational roots. So they have to be either whole numbers like integers or fractions. You can't have any square roots. You can't have a quadratic that doesn't reach the x-axis. So not everything can be factored, but a lot of them can. So step one, we're going to take this and factor out a greatest common factor if there is one. And you can probably see that with 3, 18, and 15, we're able to factor out a 3, and we'll be left with x squared plus 6x plus 5. You have got to do this GCF step. As we've said along the way, it's the most commonly forgotten thing, and if you don't do it, then your final answer won't be right because it won't be fully factored. Now that we've created this factored version with the GCF out front, I'm going to cross out the original version. The reason I do that is because it's really easy to refer back to that and use part of this original equation instead of the GCF'd version. Expression, not equation. So make sure that we're only referring to this one from now on, and to do that, I just strike through that one. I don't scribble it out so I can't see what it was. I just put one strike through across it so that I don't accidentally refer back to it. Okay, now that we've done our GCF, that was step one, check. We're on to step two. Step two, it says identify A, B, and C. Remember, A, B, and C are just our three coefficients of our x squared, x, and constant. So in this case, if we want to write it out, we don't have to write it out, but A is 1, B is 6, and C is 5. Okay, step two, we're going to multiply A times C. And to do that, we're going to do a little visual organization where we're going to make a little T chart like this. And on top of it, we're going to put the product of A and C. So A times C is 5, and I put that up at the top. So that was step two. We multiplied A times C. And then we're going to step 3 and 4, I'm going to kind of go back and forth between. So the first thing I want to look at before we start into 3 and 4 is be careful with the signs. And I'm going to give you a strategy for how to do that. So below the 5, we're going to put our signs here. So we're going to put either plus or minus in these two spots. And the way we know which one it is by the signs of B and C. So if C is positive, then we know that both factors have the same sign. So think back to perfect square trinomials. We had something minus something squared gave us a plus for our constant. And if we had something plus something squared, we got a plus for our constant. So if C is positive, then these two things have to have the same sign. So either they're both positive or they're both negative. If C is negative, then they have to have opposite signs. So either they have to be a minus and a plus, or a plus and a minus. That's the only way for that to happen. Again, think of our difference of squares. We had a plus and a minus, and that ended up with minus that constant term. So the only way for the constant to be negative is if these have opposite signs. So that's half of the picture. We know whether the signs are, so this is same signs, and this is opposite or different signs. But how do we know which of the two? So to find that, we look at the sign for b. So if b is positive, then we know that it's going to look like this one. And if b is negative, it's going to be one of these. So in this case, B and C are both positive because I have positive 6 and positive 5. So both of my signs are pluses, and I'm going to make a note of that here so that I know which it is. We'll do some more examples so you can see other cases where it's not that one, and hopefully that'll help you get used to the idea. So next it says list all possible factors of A times C. So we can do that as 1 and 5. If you have trouble factoring or if a number gets bigger, we'll talk about strategies for that a little further into the notes. But my suggestion is that you, at 1, look for a GCF, because if the number's really big, you might have missed a GCF. And number 2 is we can use the prime factorization method that we did for simplifying radicals to help us here as well. So we only have 1 and 5 as factors. You may say we also have 5 and 1, but that's redundant and it breaks the point of these signs that we wrote here. So in our factor list, the smaller number will always be on the left and the bigger number will be on the right. So this is the smaller number and this is the bigger number. And then the signs will all work themselves out. Okay, so we found that 1 and 5 are the only possible factors of 5. Our goal in this list, which our list only has one thing because this problem is very simple, is to find a pair of factors that combine to make the middle term. So we're trying to add up to b. So like it says here, add up to b. 1 and 5 add up to 6, which is b, so that's the correct pair of factors. Again, a little further into the notes, we'll look at some more complex examples that have more options than this. So what did we find? We found that this 6x in the middle right here, let me use highlighter, this 6x in the middle was actually made up of a 1x and a 5x. So we uncombined the like terms. And now we can write this as 3 times x squared plus 1x plus 5x plus 5. So that was the piece that we've been missing of how to go from standard form to factored is how do we undo combining those two like terms? And this method is giving us a way to do that. So from here you can proceed in two ways. So we get to step 5. And we want to use the area model to show how to do this. You can also, if you recall, do factoring by grouping from here. When there's 4 terms, we can factor by grouping and we'll come up with the answer that way. But we want to focus here on the area model. So what we do is take the 4 terms and put them in their correct spots. Remember that x squared always goes in the upper left. The x terms go in these 2 corners on that diagonal. And then the constant goes in the lower right corner. Now to get started, we want to fill in the outside. We look at this top row right here, and we take out whatever the GCF of that top row is. So we are going to pull out our GCF of this top row is just x. From there, we can use the boxes and puzzle everything else together, because I know that x times this number up here makes x squared. Then I know that x at the top times this number down here at the lower left makes 5x, so that must be 5. And then to fill in my last part up here, I know that it's going to be a 1 because that makes x and 5. So basically, similar to what we did in division, where we're going around and filling in the outside is kind of a little puzzle. We end up with our answer is x plus 1 times x plus 5, but remember that 3 is still there as well. So we have our GCF and then our 2 linear factors, and that would be our final answer for simplifying this expression. So yeah, that's a really simple example. The boxes aren't strictly necessary for this one, so we'll do some more complex ones, and I'll talk about when you do and don't need something at the level of the area model. So this one has no GCF because our coefficient of x squared is 1. That means we're going to go straight to the later steps. So we're going to multiply a times c and put it on top of here. A times c, 1 times negative 14 is negative 14. Then I'm going to look at my signs. So my c term is negative, meaning that my two terms have different signs, and my b term is negative, meaning that the bigger number, the one on the right, must be the negative, and the smaller one must be the positive. Now I'm going to list out factors of 14. I have 1 and 14, and I have 2 and 7, and that's it, because the next one would be 7 and 2, which is a repeat of that one. So we want to always have the smaller number on the left. There's no other way to make 14. So now I check. I have a positive 1 and a negative 14. That does not make negative 5. Positive 2, negative 7. That does make negative 5. So this is my factor pair. And I'm going to remember to bring the signs with it. If you want to put the signs here, you can. I like to separate it and then deal with it later, but it's up to you. So 2 and negative 7 are the two things that are our two like terms that we're combining to make that negative 5x. Then I fill in my x squared and my minus 14. My GCF on my top row is just x, so that means my top term here has to be x. Then this must be a negative 7, and this must be a 2. And then to check it, 2 times negative 7 is negative 14, so I did everything correctly. And my answer, there was no GCF. I just have x minus 7 times x plus 2, and that's it. So this is the kind of work that we're expecting you to show, is like, where did you find the factors and how did you write that out? Now, on this one, for today, I do want you to use the area model for all of these. But in the future, you may notice that this had a direct connection to this. We didn't really need the area model. We could just do this positive 2 gave us x plus 2, and this positive 2 gave us x plus 2, and this negative 7 gave us x minus 7. So they went directly into the factors, but that only happens if a is equal to 1. If a is not equal to 1, you must use the boxes. If a is equal to 1, you can kind of skip from the factor list straight to the answer without doing the area model or factoring by grouping in the middle. But be really careful with that, because people try to skip from here to here and not do the necessary step in the middle. So for today, even on these simple ones, you have to do the middle step on today's homework just to get practice with it and not skip a very important step, just like not skipping a GCF. All right, next one. So at this point, we'll do this one together, and then I'll let you try a few if you want to pause. So this one, a is not equal to 1, meaning we cannot skip the boxes even if we weren't on day 1. So we're going to make our little factor tree like this. There's no GCF. We have 4, 12, and 5, so there's no GCF. I'm going to multiply a times c is 20. They have the same, c is positive, so they have the same sign, but b is negative. So that means both of these must be minuses in order to create a negative 12 in the middle. So factors of 20, I have 1 and 20, 2 and 10, and 4 and 5. If you want to, like I said, you can put negatives on all of those. I prefer just to leave the sign up here. It's totally a personal preference thing. You do what works for you. So if you want to write negative by each of these, then absolutely go for it if that helps you keep your signs straight. So my like terms that make 12 are right here. Negative 2 and negative 10 make 12 in the middle. So I have minus 2x and minus 10x. I have 4x squared up here and 5 down here. So now I start by looking for my GCF on the top row. 4x squared and negative 2x have a GCF of 2x. Then I say to make this 4x squared up here must be another 2x. Now I fill in the rest of it with the numbers that are left. So we get a negative 5 down here, because that's going to combine with that 2x to make negative 10x. And then on top we need a negative 1, and then negative 1 and negative 5 create that positive 5, so everything looks good. It'll always work out, right? It has to work out, but if you check that constant and it's not actually the right number, then you made a mistake somewhere. So now that we have this, our answer, remember there's no GCF, so we don't need to write that. We have 2x minus 5 times 2x minus 1. And with that, you can hopefully see that we couldn't have skipped straight from negative 2 and negative 10 straight to this. That doesn't work out because we don't have negative 2 and negative 10 as our factors. So that's an example of why it's important that we have this method with the area model for cases when A is not 1. So for these other 4 here, I'm going to let you, if you want to, pause it and try them on your own. But I'll work through these 4, but if you feel like you're getting it, then try it on your own and then use my work to check it instead of watching passively. So I look for a GCF here. I have a 2. I am left with x squared plus 7x plus 12. I'm going to get rid of this so that I don't accidentally put something from that into the boxes. I know this is x squared and 12. What I need is my 2 other pieces, so I'm going to make my little t-chart. A times c is 1 times 12. And in this case, b and c are both positive, so we have the same sign, and they're both pluses, so plus plus. And then my factors are 1 and 12, 2 and 6, 3 and 4. So the 3 and 4 add up to 7, so those are the correct ones. So I put 3x and 4x in these boxes. On the top row, my GCF is x, so then I fill in x here, 4 here, 3 here, and then double check 3 times 4 is 12, so it's all correct. I did have a GCF, so make sure that that stays with my answer. I bring it down and then put x plus 4 times x plus 3. And this is one of those cases where a was equal to 1 after we did the GCF, so we could have brought the 3 and the 4 straight down without using the area model, but for today we're going to use the area model every time. The next one, we have a GCF of 8. Then we have x squared plus 1x minus 20. So we're going to fill in x squared and minus 20. Now we need to, I also don't think it's a bad idea at all to go down to your answer and put 8 parentheses. That way you don't forget to bring the GCF down at the end. It's a really common mistake to lose that 8 and not bring it to the answer. So it's okay to go ahead and start writing your answer at this point. So on my t-chart, I have 1 times negative 20, so I get negative 20 at the top. My signs, since I have a negative c value, are opposite. And then since this is positive, I know the bigger one is positive and the smaller one is negative. So we're going to go ahead and put factors of 20 are 1 and 20, 2 and 10, 4 and 5. And if you want, again, remember you can put the negatives here. It's up to you. I don't know which works better for you, putting it or not, but maybe put it. So in the middle, we needed a positive 1. So negative 4 and positive 5 will make that happen for us. So we're going to put negative 4x and 5x as our 2 like terms. The GCF of the top row is just x, meaning we have x up here. We have a 5 and a minus 4. So we can check that 5 times minus 4 is minus 20, so that's all correct. And we have x plus 5 times x minus 4. Yeah, easy. And then the next one has an a value that's not equal to 1, meaning we have to use the area model. And we don't have a GCF, so we can go ahead and fill in 2x squared minus 15. Our a times c, we have 2 times negative 15 gives us negative 30. Looking at signs, this is negative, so they have different signs, and this is negative, meaning the big one is negative. So we have negative and positive. So we have 1 and 30, 2 and 15, 3 and 10. And if it wasn't clear, I'm just going up numbers on the left and seeing what works. So 4 doesn't work, 5 does work, and now if I kept going, I would cross over to the high side. So that's it. Those are all the factors. So I'm going to go ahead and put the negatives here. I think probably that's the better way to do it. And then we're looking for a -7. So 3 and -10 is my correct factor pair. So we're going to put 3x and -10x. So on the top row, my GCF is just x. But on top then, I need 2x, which is the GCF of the first column. Then I need a -5 here, and a +3. That gives me -15 in that spot, so that's correct. There was no GCF, so my answer is just x minus 5 times 2x plus 3, and we're done with that one. The last one, there's no GCF, so we can go ahead and place 2x squared and 20, and we're going to put a times c. 2 times 20 is 40. Our signs, we have a positive here, so they're the same sign, and a negative here, so the bigger one is negative. Or they're both negative, sorry. Same sign and they're negative. It's true, the bigger one is negative, but also they're the same. Okay, so we have, to make 40, 1 and 40. We have 2 and 20. 3 doesn't work. 4 and 10 works. 5 and 8 works. And then we cross over because 6 and 7 don't work. So we're trying to find 13, which is going to be the 5 and the 8. Remember, both of those are negative, so we have minus 5x and minus 8x. Our GCF on the top row is going to be just a single x, meaning we need the 2x up here. And then we need a -4 and a -5. And the -4 times -5 does make 20, so our answer is correct. And since we didn't have a GCF, we just do x minus 4 times 2x minus 5 as our final answer. So this is what we're doing to practice this. As you get better at factoring, you'll be able to do this without all of the steps, and that's okay. So for today, we want you to practice all the steps, and at the beginning, while this is a new topic, we want you to practice all the steps. What you will get to be able to do later as you move more advanced in this and move toward Algebra 2 is for something like this last one, instead of writing out all of these things, you're going to just be able to say, okay, I'm going to make this into linear factors. I know that this has to be made of a 2x and an x. And then you're going to say, okay, what do I need to break this into to make this -13 happen? So we know these are both negatives the same way we did before. And I say, okay, I'm just going to kind of pick numbers and see what works. So for this one, it would be 5 and 4. So I would have the 4 here to make -8 and the 5 here to make -5. But really, that feels very magical, like you don't know where things are coming from. If you practice this a lot and get better at it, by the time you get to Algebra 2, you should be able to do more of that and not rely on the T-chart and the area model as much. But for now, we do want you to use them to kind of internalize and learn these skills. But later, you want to kind of be able to factor quadratics just by looking at them without really having to do all of these steps.